Hi class, let's take a look at example 3. And in this case, what they want us to do is take a look at a scenario where you're basically going to have a family that has a total of 3 children. The original problem was 4, but I made it 3 because it doesn't fit on the screen. I usually do this problem at on the board, and literally we fill out the board. So in this case, sorry you guys, I gave you the wrong picture, but I had to make it smaller. So in this case, we're just talking about a family that's going to have a total of 3 children. Now they want a tree diagram. So for a tree diagram, you just have to declare it, the event. So I'm just gonna so in this case, let B equal to a male, or having a male, and then G equal to a girl or a female. Whoops, let me fix that. So a female. Okay, and we're going to look at the events in the following format. So this is going to be event number 1. And technically, event number 1 consists of the first birth. So the first birth, in terms of what we're looking at. And what we're looking at here is the events can only be a boy or girl, and you're talking about a single birth. So event number 1 could be a boy, or it could be a girl. Now, for the second event, and let me just write it as event number 2, if the first one was a boy, then you could have, and let me write it in green, well, the second one would be a boy, or it could be a girl. If the first one was a girl, you could actually have a boy, or technically a girl. Now, the tree diagrams represents, well, any of the possibilities that you could have. So if you look at the actual upper branch, in this case, this branch and that branch, that represents a branch of a family of 2 boys. So a boy on the first trial and then a boy on the second one. So they want a total of 3 kids, or 3 trials, or in this case 3 events. So event number 3, we're going to actually rewrite it as a boy, or an actual girl. Whoops. A boy or a girl, a boy or a girl, a boy or a girl. And that's technically all the events. They want us to list them on part B here. So let me actually read the branches. So if we look at the actual branches, you're looking at the first event being boy, boy, or boy. So technically that's one possible family. This will be boy, boy, boy. And then if you look at, if you go along that branch, event number 2 is going to be boy, boy, and girl. So I'm basically going in this direction, boy, boy, and then technically here, girl. Event number 3, it's going to be boy, girl. So boy, girl, and then technically boy. Event 4 is going to be boy, girl, girl. Event 5, it's going to be, so girl, boy, boy. And I'm looking at this branch now. So girl, boy, boy. Event 6, it's going to be girl, boy, girl. So girl, boy, girl. Event 7, it's going to be girl, girl, boy. And the last event, let me write it so that you guys can see it. Let me use yellow. So it'll be girl, girl, girl. So we're looking at 8. This is going to be girl, girl, girl. That is basically each one of the branches, and it technically represents a different type of family. Once again, the first event, which is boy, 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 I'm reading it as boy, boy, and boy. The second one would be boy, boy, and technically girl. That would be this one out here. That would be it for this actual sample space. Now let's take a look at event C. And event C, let me declare it because it could change. They want us to find the probability that all children are 2 boys. So I'm just going to say let A equal to having 2 boys. So in this case, the probability of A is equal to, now out of the sample spaces, we have to actually find which one of these have 2 boys. So in this case, event number 2 has boy, boy. Event number 3 has boy, boy. That's 2 boys. And actually that's it, because event 4 has 2 girls. So event 5, girl, boy. Oh, actually, wait. This one has 2 boys. So those are your 2 B's. And I think that's it. So in this scenario, the probability of A, it's going to be 3 out of 8. So 3 out of 8, it's going to be exactly 0.375. So let me circle it. That's an answer, and that's another answer. The next event, they want that you have 3 girls. So let me declare it. In this case, I would just say, so let A equal to 3 females. So the probability of A is equal to, so now we're looking at all the events that actually have 3 G's. So in this case, we're just looking at this one. That would have 3 girls. Everyone else, it's going to be a combination. So in this case, 1 out of 8. So this is 0.125. Last one, and I apologize, this is a word issue that somehow fitted in there when I made the PDF file. So this is having 4 boys. So we already use A. So in this case, let me call it B. And in this case, it's having 4 boys. So having 4 boys. So the probability of B is equal to, well, there is no 4 boys because I modified the event to only 3 children. So in this case, you would just say this is 0 out of 8. So this will be 0. Now, I just noticed a basic technicality. So on the previous one, you can actually leave it like that. But what you're going to see is that the problems on the homework, every one of those will be given a letter. So let me just use this one as C, and this is now the probability of C. And this is on the previous one because technically we already used A on the first one. Theoretically, every time that you declare A, it changes. It's a variable. But if we were to use A for something else, like a final sentence, it would be confusing. So on all the problems, what is customary is that we use one letter for one event, change it for another event, and so on. So here, I actually didn't notice that we had already used the values of C. Of A.